6.4, dependent and independent events. Let's do an example. What is the independent events? Let's say you have a 2-coin tossed. First one you toss is head. The second one you toss it, is the result depends on the outcome of the first one? No, there are two separate independent events. The events that not affecting the result of the other events, they are independent events. So example one, simple independent events. A coin is flipped and turned up head. What's the probability that second flip will turn up head? Since these two are independent, so the first one that is head will not affect the second one, right? Probably that the second will be head is 50%, of course, because there's two sides, is 1/2. The total event is 2. One of that is head, so 1/2 is 0.5 or 50%. A coin is flipped 4 times and turn up head each time. What's the probability that the fifth trial will be head? Again, the fifth trial will not be independent of the previous events. So again, 50% chance that's going to be head. Find the probability of the tossing 5 heads in a row. So since we have 5 head in a row, well, we can do the tree diagram. So here is the first one head, right? The first one is head or tail. The second one, if there is head, the second one is head or tail. The third event is head or tail. If this is tail, it's going to be head or tail. We do it for each one. The fourth one going to be head, tail. You put them. And the fifth one is going to be head, tail. You do that. Or you can set that for total events, because you're doing 5 of that. It's going to be 2 multiplied by 2 multiplied by 2 multiplied by 2 5 times, right? 1, 2, 3, 4, 5. Make sure it's like a stage. In the first one, the total event is going to be 2 head or tail. The second one, you flip it, going to be head and tail. And our independent, so multiply each other is going to be 2 to the power of 5. That's 5 of them, right? 1, 2, 3, 4, 5. Yeah. And what is the probability that it's going to be head? So just one event will give you head, 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 right? So as you see, 2 to the power 4, 2 to the power 5 is 32. Is 1/32. The probability of everything, the 5 in a row would be head. So comment, okay, you don't need to do that part. So probability of 2 different independent events. Now you have a die. Die is 6-sided, and on each side is 1, 2, 3, 4, 5, 6, right? What is the probability of flipping a head and rolling 5 in a single trial? So flipping a head is 1/2. You have a coin, right? You have head or you have tail, right? Then you put it. So the probability that you will have head is going to be 1/2, because one of the total is 2, going to the denominator, 1 is head. Rolling 5 in a single dot has 6-sided, right? Then rolling 5 is just one event. One side is 5 on it, so it's just 1/6. The probability for rolling 5 is 1/6. Since they are independent, you just multiply these two together and play 1/12. So it's a probability that you roll head and you roll 5 in a die. So so when the events are independent, so probability A and B happening at the same time is probability of the one multiplied by the probability of the other. PA multiplied by probability of B. Supplying product rule for independent events. So So Soling travels the same route to work every day. She has determined that 0.7 perfect, that she will wait for at least one red light. So 0.7, she's waiting for a red light, okay. And 0.4%, 0.4 is a probability that she will hear his favorite song. What is the probability that Soling will not have to wait? No red light. No red light is 1 minus 0.7, right? So not have to wait for a red light and we'll hear her favorite song. And favorite song is 0.4. So since these two events is independent, so the probability at the same time that happening is just this two multiplied by each other. Second one, what are the odds in favor that Soling have to wait? So have to wait for lights is going to be 0.7%. And not hearing her favor, not hearing the favor is 1 minus 0.4. So this is going to be probability of A, okay? I say you want to have the odd in favor. Let me just look at this number, see what is the P of A here. We calculate 0.42. So here is 0.42. So odd in favor is equal to the P of A divided by P of A prime is 1 minus 0.42. So you do that, this give you the odd in favor of that event. So it's going to be 21 over 29. That would be odd in favor of that event. Let me just erase this. Now, conditional probability. So P of B, this condition A, is the probability of A. This will tell you the probability of A when the B already occurs, right? What is the probability of the A when the B already occurred? So let's just say that the kind of probability of B is the probability that B occurs, that A has already occurred. Oh yeah, probability of the B when A already occurred, okay? I'm just correcting myself. The PB A is B line A is the probability of B and A already happened or occurred. Probability of the two dependent event. The professional hockey team has 8 wingers. 3 of these wingers are 30-goal soccer or snipers. So 3 of them is a sniper. Every fall, the team plays exhibition match, the club of team. In order to make this match more interesting for the fan, the coaches agreed to select 2 wingers at random from the pro team to play for farm team. Also, probably 2 sniper will play for the farm team. Okay. So let's A to be the first winger is a sniper and second winger is a sniper. So 3 of the 8 wingers are snipers. So probably the first winger select being a sniper is 3 over 8. So there are totally 8 people. So it didn't say that, but I should assume that there are 8 people gonna, yeah, I said, okay, team has 8 wingers, means 8 player we have, right? So the probability that the first selection is a sniper, because 3 of them is sniper. So 3 out of 8 is a probability that you choose for your first selection, you choose it to be a sniper. If the first winger selected is a sniper, then there are 7 remaining winners, right? So you choose the 1 is gone. So it's 8 is 7 now. And now if you don't have the third, one person have been chosen. So you have 2 out of 7, right? So this gives you the probability that of A when B already, of a B when A already happened. A is the probability that the first one is a sniper. Assuming the first one is a sniper now, or second is a sniper is 2/7. So applying the fundamental counting principle for probability of randomly choose sniper for the farm. So what we do, we just multiply this together. So 3/8 multiplied by 2/7. They are independent selections, right? It's going to be 3/28. So 3/28%, 28 or 10.7% the probability of the 2 professional sniper will play for farm team in exhibition game, right? Now, product rule for dependent events. So if these 2 events that like that one is dependent, so you just choose the first one, and the second one is depends on the first one, right? Because one of them is gone now, is the number is decreased for selection and the total. So this is the rule. P of A and B is equal to P of A multiplied by P of probability of B when A already occurred. Now, conditional probability for compound probability. Let's just do that. Serena's computer sometimes crashes while she's trying to use email. Okay. Outtake, when the outtake hangs, stop responding to compound. Serena is able to choose outtake without a system crash. In a computer magazine, she read that probability of outtake hanging is 15 minutes, period is 2.5%. So take out is 2.5%. Why the chance of outtake and operating system failing is 1%. Outtake and operating system. Operating system fail is 1%. If outtake is hanging, what is the probability that operating system will crash? So this is conditional probability when this system will crash. It's a system crash when it is outtake is hanging, right? So if you just look at that, P of A and B is equal P of A multiplied P probability of the B when A already happened. We want to look at the probability B already B when the A already happened is take out and operating system will crash. P of A is probability that take out happen, and B means both of them happening at the same time, which is given. Take out and operative is 1%. So 1% here, 2.5% here. We just rearrange it for probability of B when A happening. So you do that, 1 divided by 2.5 is 0.4 or 40% chance. Okay, again, you do the even questions and send your answers to teacher.